All right, geometry friends, here we go. So after yesterday's lesson with the robot saying you might be a little bit confused or feel like you're lost, but that's okay because today is a practice day and a review day. Tomorrow is a practice day and another review day. So we get a couple days to work things out, do some practice and figure things out before you actually have a quiz. Quiz coming up in a couple of days. So let's just do some simple practice together. Let's go back to the robot thing. You are a member of the robotics team and are in charge of programming a robot that will pick up ping pong balls. The arena is a rectangle with dimensions of 80 feet by 60 feet. You sketch the arena on grid paper, aligning the southwest corner of the room as the origin. You initially set the robot to move along a straight path at a constant speed. In the sketch, the robot's position corresponds to 10:20 at time 2 seconds and the point 40:60 at time 8 seconds. We're going to use this information and go through some questions similar to what we did yesterday. What is the equation of the path that the robot takes? So in order to write the equation of a line, we are going to use our point slope form for the equation of a line. And point slope form was y minus y1 equals m times x minus x1. The x1 and the y1 gets replaced with a coordinate point, x value and y value, and the m is our slope, which means the first thing we need to find is our slope. So based on the coordinate points that were given, our position points of 10:20 after 2 seconds and 40:60 after 8 seconds, why don't you pause the video and find the slope? So our slope is 4/3, and then it says, what is the equation of the path of the robot? So our equation, either using the position point 10:20 or using the position point 40:60, doesn't matter which one you use, but our equation has two options, and they're right there on your screen. The next thing it asks, what is the distance that the robot covers in those 6 seconds, from 2 seconds to 8 seconds? So you're supposed to know your distance formula. We have two coordinate points. So we're going to plug in our coordinate points into our distance formula, pause the video, and find your distance. So our total distance is 50 feet. So across those 6 seconds worth of time, the robot covered 50 feet. So if it did 50 feet in 6 seconds, what is the speed in feet per second of the robot? 50 feet in 6 seconds. So we can either simplify that to 25 over 3 or write it as a decimal 8.3, repeating 8 1/3 feet per second. Now we know how fast the robot's moving. Next, where is the initial starting location of the robot at time equals 0? So this is the three-step process that we did yesterday with the robot, where we had to work backwards and figure out where the robot started. So the first thing we did is found our change in x, and we did our change in y. We're going to go through the x coordinate first, and then I'm going to let you try to do the y coordinate on your own, and then we'll see how you did. So the first thing we did, we found the change in distance. So we know that the robot horizontally is going to move 30 feet across those 6 seconds worth of time. So if it moved 30 feet in 6 seconds, then I need to know how far it's moving per second. So I'm going to take the change in distance divided by the change in time. So now I know that it's moving 5 feet for every 1 second. Now, the first position point that we know was after 2 seconds worth of time. If I know the robot is moving 5 feet for every 1 second, then the x coordinate from the point when it was a time of 2 seconds. So at 2 seconds, remember, the robot was located at the point 10:20. That's after 2 seconds. So what we need to do is subtract out 2 seconds worth of horizontal distance. If it moves 5 feet horizontally for every 1 second, then I'm going to subtract out 2 seconds worth of distance. Okay, so that gives me its original starting position for my x coordinate as 0. Now what I want you to do is try to do those same 3 steps with your y coordinates, and let's see if you end up with the right value. So pause the video, try to do the y coordinate, and then come back and we'll see how you did. It's important to try to do these things on your own. It's okay to make mistakes. Through mistakes comes learning. All right, so the change in y is 60 minus 20, or 40 feet vertically. So there's a change in 40 feet vertically. That 40 feet of change happened over 6 seconds worth of time. So when I do 40 divided by 6, I get 6 2/3, or 6.6 repeating. That's for every 1 second. But this change, this vertical change in location, happened over 2 seconds worth of time. So then I have to double that and subtract it from the y coordinate where we first found its location after 2 seconds. The y value of 20 is the y coordinate that we were first given. And then minus the 2 seconds worth of distance, because we're working backwards to see where it started, gives us a final starting position of 0 and 6 2/3, or 0 and 6.66666 repeating. Okay, part E. At the point 4060, this is after the 8 seconds, the robot is programmed to rotate 90 degrees clockwise and begin a new path. What is the equation of the new path? Write the point slope form and the y-intercept form. So we're going to do both. All right, well, the point slope form is easy. We just have to take the slope that we have from part A. So if you look up your paper a little bit, the slope that you have written down in part A is 4/3, and we need to use the perpendicular slope. So our perpendicular slope would be -3/4. And then we can use the position point, 40 for the x, 60 for the y, and write our point slope form. Now, to get our y-intercept form, point slope form can just be transformed into the slope intercept form by distributing the -3/4. So distribute the slope, rewrite it. Go ahead, distribute the slope. And then once you have the slope distributed, you want to get y alone. So then you're just going to subtract. You're going to subtract the, add the 60 to both sides. So when you distribute the slope, then you add the 60 to both sides. There you go. There's your slope-intercept form for the equation. For part F, the robot continues on its path from part E. So we have 2 different equations that describe the robot's path right now. What is the point of impact with the east wall of the arena? Now look at your graph at the top of the page. The east wall of the arena is a vertical line that can be described using the equation x equals 60. So what we can do is take our equation and plug in the x value of 60. The y value tells us where it's going to hit the wall. Last part, at what time to the nearest second did the robot hit the east wall? Well, in order to know what time it hit the east wall, or basically what they mean by what time, how long after it started moving did it take for it to hit the east wall? What we have to do is find our distance. So distance from the turn to the wall is what we're looking for, because we have already found out the distance that it traveled. So from the turning point to the intersection of the wall is 25 feet. Our distance of 25 feet equals rate times time. That's 3 seconds. But remember, what we just found, and if you look at my little sketch here, what we just found was how long it took after the turn for the robot to hit the wall. We know this position point of 4060 was after the first 8 seconds from its starting position to that point was 8 seconds because that's information that was given to us. 8 seconds after it started moving, it is at position point 4060. Then it turns 90 degrees and hits the wall. That was 3 more seconds. So that means our total time is going to be 11 seconds total. It's tricky because we have to add in the first 8 seconds to the 3 seconds after the turn. Okay, so there's some practice with you together. You have answer keys to access all the other answers to all the other questions. Make sure you go and do the last page. It's a nice video game application using FIFA, World FIFA from EA Sports. So take the time, do things well, do things right, learn it the first time, and I will see you guys soon. All right, be well, thank you, and take care.